Hi students, Santosh here. Today I am going to deliver my lecture number 6 on highway engineering and which consists of highway materials. This is very important part of highway engineering and every field engineer as well as engineers who are working in the offices must know the knowledge of highway material. So I am once again requesting you for the for those who have not subscribed my channel, I am asking them to subscribe my channel, and the persons or the interested students who have subscribed my channel, I am once again congratulating them for subscribing and for getting more and more things about civil engineering. So let us start with the highway material. First of all, you must know the highway is resting on the soil, and that soil is the subgrade soil, or that part is called as a subgrade. So what is importance of soil? Because soil provide the base to the pavement, so it should have sufficient strength to take the load of the pavement, and it is also to take that load in adverse weather conditions as well as adverse groundwater conditions. So subgrade soil should be strong enough for that. And what are the desirable properties of a soil as a heavy material? Are the first is of course strength or stability, second is the incompressibility, third is permanency in strength. That is very important because some soils are not showing the permanency in strength, so that permanency in strength is important. Then minimum changes in volume and stability in adverse condition, as discussed earlier. Adverse conditions are the weather conditions or groundwater conditions. The soil should have good drainage also, and it have ace of compaction. What is the compaction? Compaction means increasing the dry density of soil. So how we can increase the density? By reducing the voids. How we reduce the voids? By way of compaction. So the soil should be compactable, so you should get the maximum dry density and you should get the maximum strength. That is the importance of the soil. Then let us discuss about one strength based classification of fine grained soil, that is nothing but the group index. And group index is calculated by one formula. That group index value ranges from 0 to 20, and 0 group index value means the soil or subgrade soil has a more strength, and 20 means that subgrade has less strength. So this is the reverse way of measuring the strength in group index, and group index is calculated by empirical formula 0.2a plus 0.005 AC plus 0.01 BD, where what is A? A is the portion of material which is passing through 0.074 mm sieve, and the percentage is greater than 35 but not exceeding 75. What is the B? That is also portion of material or soil passing through the 0.074 mm sieve, and the percentage is greater than 15 but less than 35. What is C? C is the value of liquid limit. In excess of 40 means that liquid limit should be greater than 40 and less than 60. And what is the D? D is the value of plasticity index. What is the plasticity index? That is numerical difference between liquid limit and plastic limit, and that value exceeding 10 and not more than 30. That is D. The value of grip index lies between 0 to 20 as discussed earlier. Higher the value, poorer will the soil. 20 means poorer, 10 means medium, 0 means stronger subgrade material. So you must know this group index classification or group index of soil. And what are the different factors on which the strength characteristics of the soil is depending upon? Strength of the soil is basically depend upon the soil type. Which type of soil that is? If that is a black cotton soil, or that is fine grained soil or coarse grade soil, that is very important. Moisture content, that is also important. That water absorption of soil is very important to determine the strength. Then dry density of soil, that is most essential part for the pavement construction. Then internal structure of the soil, that is also important, and the type and mass of stress application, that is also important, and these factors are remembered by one simple Tm di Tm. Tm means T means type, M means moisture content, D means dry density, I means internal structure of soil, and Tm means type and mass of stress application. So you must remember by some simple tricks. How you evaluate the soil strength? The soil strength is basically determine the three types of tests. First are the shear test, that is used to determine the shear strength of the soil, that is nothing but the cohesion and angle of internal friction. Second are the bearing test, and third are the penetration test. So you must know the shear test, penetration test, and bearing test. What are different types of shear test? You must know in soil mechanics or geotechnical engineering, that are the direct shear test, for which box is used to determine the cohesion and angle of internal friction. Triaxial compression test, that is used to determine C and phi also. Unconfined compression test, that is also used to determine the shear strength parameters of the soil. And vane shear test, which is used in the field to determine the shear strength by means of a rotation of the blades in cohesive soils especially. You must know that. What is the bearing test? That is CBR test is very important, that is California bearing ratio test. Second is the cone penetration test, and penetration test are also cone penetration, that are the standard penetration test, dynamic cone penetration test, or static cone, dynamic cone penetration test, and plate bearing test. These are the different three types of tests used to determine the strength of the soil. You must know that three types of tests. Then CBR. All the time short note is asked in the descriptive type of examinations, and also some part of MCQs are given on the CBR. So you must know the CBR. CBR is used for determining the strength or stability of subgrade material. That is very important. You have to determine the strength or stability of subgrade material. What is the CBR apparatus? CBR apparatus is nothing but the 150 mm diameter mold with base plate also, and cylindrical plunger is used of 50 mm diameter for that loading. And to measure the deflection, the dial gauges are used. So the load values to cause the 2.5 mm penetration and 5 mm penetration are recorded, and these loads are expressed in terms of percentage standard load values at respective deformation levels to obtain the CBR. And that standard values are 1370 kg and 2055 kg for 2.5 and 5 mm penetrations. And the normal curve, which is load, that normal curve is plotted which has convexity upwards, load versus deflection. You must know that. And if concavity is upwards, you might apply the correction factor. Okay. Then what is the formula for the CBR as expressed earlier? Load or pressure sustained by the specimen at 2.5 and 5 mm penetration divided by standard values at 2.5 and 5 mm penetration multiplied by 100 gives you the CBR value. CBR value at 2.5 mm penetration. So lesser penetration, CBR is more, and for 5 mm penetration, CBR is less. So you must remember, for lesser penetration or 2.5 mm penetration, CBR values are more than that of 5 mm penetration. And CBR is basically arbitrary strength test. You must know that, and it is not used to determine the soil strength parameters such as a cohesion as well as angle of internal friction. And material passing through the 20 mm sieve is only used for this CBR test. And this test is also carried out for the sub base and granular base course materials. So you must know the CBR. CBR for the black cotton soil is also less, because you know that the penetration, it depends upon the penetration. The value is 0 or 0 to 2%, and for medium size murum it is 20 to 30%, and for aggregates it is more than 40%. So you must know the CBR values of different materials. You may refer any geotechnical book or soil mechanics book for that. The second important part, and which occupies the more and more part of pavement, is the aggregate. So aggregate is nothing but the part of stone or chip of stone, is that is not nothing but the stone aggregates. And stone aggregate, what are the desirable properties? You studied in building material also. that are the strength, second is the hardness, third is the toughness, then durability, then shape of aggregate is important, plays important role in the strength parameters, and adhesion with the bitumen. These are the important properties. What is strength? Strength is resistance to the load or stresses. What is the hardness? Hardness is to resist the abrasive action of the traffic. For that, hardness is required. What is toughness? Toughness is to resistance to impact for the heavily loaded vehicles. That is the toughness. What is durability? Durability is nothing but the resistance to the weathering action. Shape of aggregate means too flaky or too elongated aggregates are not used because they have not sufficient strength. So they are not used in road construction. Rounded shape aggregates or some angular shape aggregates are used. Adhesion with bitumen, the aggregate used in bitumen pavement must have less affinity to the water. They should not be hydrophobic. They have less affinity with the water and more affinity with the bitumen. That is the adhesion with the bitumen. And depending upon these desirable properties, the test conducted on the aggregate are the crushing test, second is the abrasion test, third is the impact test, fourth is the soundness test, then shape test, specific gravity and water absorption test, and bitumen adhesion test. These are the tests depending upon the properties or requisite properties for that aggregate. What is the crushing strength? Crushing strength is relative measure of resistance to crushing under gradually applied compressive load. Gradually applied compressive loads. Okay. And it is calculated by formula W2 divided by W1 multiplied by 100, where W1 is equal to what W1? W1 is the weight of dry aggregate passing through 12.5 mm ISCU and retain on 10 mm ISCU. What is W2? Weight of crushed material or crushed aggregate passing through 2.36 mm sieve. And the aggregate crushing value for good quality aggregate to be used for base course shall not exceed than 45, means it should not have more crushing than that of 45%, and value for the surface course it should be less than 30. For surface course crushing will be more, so value of crushing value should be less, that is less than 30%, and for base course that value might be somewhat more and that should not exceed 45%. So you must remember these values. Then abrasion test. Abrasion test on the aggregate. There are three different tests and you studied one test in college, your Los Angeles abrasion test. Devil abrasion test and Dury abrasion test is there. The name, there is nothing difference in between these three tests, but difference is the type of machine, that is very important. And the percentage passing through the 1.7 mm sieve after carrying out the abrasive charges or abrasion action, it is expressed in terms of original weight of sample to the 1.7 mm passing. So 1.7 mm passing after abrasion is very important, and 2.36 mm passing for crushing strength. Then impact test. Impact test formula is similar to the crushing test, that is W2 divided by W1 into 100, where W2 or W1 is equal to weight of aggregate, same that of passing through 12.5 mm ISCU and retain on 10 mm ISCU. What is W2? Weight of fine retain, it is very important for impact test. Weight of fine aggregate retain, and in crushing it is passing through, that is very important. And the aggregate impact value is less than 30 for wearing course, less than 35 for bitumen macadam base course, and 40% for less than 40% for water WBM base course. So you must remember that 30, 35 and 40% values. Then soundness test. Soundness is resistance to the weathering action, resistance of aggregate. Clean dry aggregate of specimen of specified size range is wetted. It is immersed in the saturated solution of sodium sulfate or magnesium sulfate, and the average loss in weight of aggregate is to be used in pavement construction at 10 cycles should not be exceeded than 12% when tested with sodium sulfate and should not be greater than 18% when tested with magnesium sulfate. That is very important for soundness test. Then shape test. Shape test, two tests are important. First is the flakiness index and second is the elongation index. The flakiness index of the aggregate is the percentage of weight of aggregate particle whose least dimensions or thickness is less than 0.6 of their mean dimension. 0.6 of their mean dimension is important. This test is applicable for sizes larger than 6.3 mm. For that, the one bracket is used where there are different shapes of aggregates are mentioned. And elongation index is the percentage by weight of particles whose greatest dimension or length is greater than 1.8 times of their dimensions. So 1.8 times of their dimensions for elongation index, and thickness is less than 0.6 of their mean dimension for flakiness index. And one angularity number is calculated by formula 67 minus 100 W divided by Cg, where W is equal to weight of aggregate in the cylinder, C means weight of water filling in the cylinder, and G is the specific gravity of the aggregate. The angularity number for the aggregates used for road construction varies from 0 to 11, that angularity number. Specific gravity for the stone, you must know that it is ranges from 2.6 to 2.9 depending upon the type of rock, whether it is sedimentary, whether it is metamorphic, or whether it is igneous. For igneous rock, the value of specific gravity is more, and water absorption should be less than 0.66% for road construction, but basically depending upon the strength parameters, it may take up to 1%. Bitumen adhesion tests are conducted in laboratory are the static immersion test, dynamic immersion test, chemical immersion test, immersion mechanical test or mechanical immersion test, and coating test. You must remember these tests for bitumen adhesion. Bitumen material, there are basically two types of bitumen material. First is the bitumen and second is the tar. Bitumen is obtained by the distillation of petroleum crude. That is very important. Bitumen is obtained by distillation of petroleum crude, and tar is obtained by destructive distillation of coal or wood in the absence of air. What is destructive distillation? It is carried out in the absence of air. And bitumen is obtained by only distillation of petroleum crude. Test on bitumen. There are various tests conducted on the bitumen, and all tests are important. Penetration test, ductility test, viscosity test, float test, specific gravity test, softening point test, flash and fire point test, solubility test, spot test, loss on heating test, and water content test. These are the different tests conducted on the bitumen. Penetration test, it is used to determine the hardness or softness of the bitumen by measuring the depth to which the standard loaded needle will penetrate vertically in 5 seconds. The time required to penetration is 5 seconds. That is very important. That 5 seconds is sometime asked in the examination. And 80-100 gains means penetration value of bitumen in the range of 80 to 100. And 30-40 means penetration range in a range of 30 to 40. And 30-40 grade is used in hot weather such as in Solapur or Nagpur, and 80-100 is used in cold weather situations such as Mahabaleshwar or Pune. Ductility test. The ductility is expressed is the distance in centimeter. Penetration is distance in mm, but ductility is distance in centimeter to which a standard brick weight of bitumen can be stretched before it thread breaks. There are two brick weights are used, and in between that two brick weights the bitumen is filled, and two brick weights are stretched, and the value of that thread breaking is calculated. The test is minimum ductility is conducted at 27 degrees Celsius. That is very important. And the rate of pull is 50 mm per minute. Distance is measured in centimeter, but the rate of pull in mm is 50 mm per minute. The ductility values of the bitumen varies from 5 over 100 for different bitumen grade. Value of 75 centimeter can be specified by ISI for bitumen of grade 45. So there are different values, and you needs to be remembered if more tough question papers are asked. So you must refer various books on highway engineering, especially Khanna and Justo is the Bible of highway engineering. You must read that book for getting more and more ideas clear regarding highway engineering. Then viscosity test. Viscosity is measured with the help of orifice type viscometer. In this method, viscosity is measured by determining the time taken by 50 ml of material to flow from a cup through a specified orifice. Means The flow of that bitumen is measured from that cup to orificimeter. That is the viscosity test. Higher the viscosity of the binder, higher will be the time required. If viscosity is more, more time will be required to flow from that cup to orificimeter. The next test is float test. That float test, the procedure is given, and the higher the float test value, the stiffer will be the material. If the float value is higher, the stiffer will be the material. That is important. Specific gravity. Specific gravity is measured with the help of pycnometer. You know that pycnometer. It is used to measure the specific gravity of soil also. The standard temperature is 27 degrees Celsius. That is very most important. For specific gravity test of bitumen, the standard temperature is 27 degrees Celsius. And the specific gravity is determined either by using pycnometer or by preparing the cube-shaped specimen in semi-solid and solid state, and by weighing in the air and water. That is another method other than pycnometer. Generally, the specific gravity of pure bitumen is in the range of 0.97 to 1.02. The specific gravity ranges from 1.10 to 1.25 for the tar, and for cutback bitumen it may be lower depending upon the type of and properties of the diluents, that is dilutants or diluents. Softening point test. For softening point test, the apparatus used is ring and ball, or ring and ball test. We may term it as a ring and ball test. The softening point is the temperature at which the substance attains a particular degree of softening under a specified condition of the test. That is important. Higher the penetration value, lower the softening point. Penetration value is higher, lower will be the softening point. Flash and fire point test, that are the tests at which proper precaution to be taken to avoid the fire hazards. And flash point is the point, and flash point and fire point both are the lowest temperature. Even though these are the higher temperatures, but that point is measured at that lowest temperature. So flash point is the material is the lowest temperature at which vapor of a substance monomentarily takes fire in the form of flash under specified condition of the test. The minimum specified flash point of the bitumen is 175 degrees Celsius. So the flash point of bitumen is 175 degrees Celsius. And fire point, for fire point which type of apparatus is used up? That Penske-Martin's closed cup or open cup apparatus is used up. Penske-Martin's, you must remember that. And the fire point is also lowest temperature at which the materials get ignited and starts burning under specified condition of the test. That is the flash. Flash point, monometry takes the flash, and fire point, it starts the burning. That is very important. Cutback bitumen. Cutback bitumen is defined as the bitumen, the viscosity of which is reduced by volatile dilutants. That three types of cutback bitumen are there. That is rapid curing cutback bitumen, medium curing cutback bitumen, and slow curing cutback bitumen. Then after cutback bitumen, we discuss the bitumen emulsions. Bitumen emulsions are the cutback with the lowest viscosity, is designated by numbers or numerical 0, 1, 2, 3, 4 progressively. And if number increases, thicken more viscous cutback as the number increases. If number increases for that bitumen emulsion, it thickens. Bitumen emulsion is the liquid product, that is very important. And emulsions, where it is used, emulsions are used for pothole and repair work. That is very important, and it is also used in soil stabilization. So emulsions are used in patchwork, in maintenance works, and in soil stabilization. And that emulsions are also classified as rapid setting, medium setting, and slow setting. And rapid setting is used for surface dressing, medium setting is used for premix with coarse aggregate, and slow setting is used for fine aggregate mixes. That is very important. Then comparison between bitumen and tar. Okay, bitumen is the petroleum product, that is very important, and tar is obtained by destructive distillation of coal or wood. Bitumen is soluble in carbon disulfide and in CCI4, but tar is soluble in toluene only. More weather resistance properties bitumen have, but the less weather resisting properties for the tar. And bitumen is less temperature susceptible, but the tar is more. So bitumen is used for road construction rather than tar. Okay, And for more details and for more notes, you may please contact my administrator, or you may write me on email, that is svkulkarni72 @gmail.com, and I am going to deliver my next lecture on the pavement, which is very important topic of highway engineering. There are two types of pavement, as you know, the rigid pavements and flexible pavement, and I am going to deliver that depending upon the availability of time. So don't miss my further lectures on the highway pavements. And once again, congratulating you for subscribing my channel, and see you. Bye bye. Take care, and please watch my channel till the end. Bye.